Ever pondered how the world of data science manages to find patterns and correlations in enormous sets of unstructured data? One of the key players behind the scenes is the Kohonen Self-Organizing Feature Map, or KSOFM. The KSOFM is a type of artificial neural network that is trained using unsupervised learning to produce a low-dimensional, discretized representation of the input space of the training samples, called a map. This map aids in visualizing high-dimensional data, which is why KSOFM holds a significant place in the realm of data analysis and pattern recognition. So, how does this sophisticated algorithm work? Well, it's a systematic process that takes place in a series of steps. To kick things off, the algorithm initializes the weights. These weights are typically small random numbers. Remember, the weight vector's dimension is the same as the input vectors. Next, the algorithm selects a random vector from the input data set. It then compares this vector to all weight vectors. In essence, it's a competition to find the weight vector that is most similar to the input vector. The weight vector that emerges victorious is called the best matching unit, or BMU. The BMU and its neighboring neurons then get rewarded with an update to their weights, bringing them closer to the input vector. This process is called neighborhood function. The neighborhood radius, the area in which the neighboring neurons are updated, decreases over time. This ensures that as the algorithm learns more and more from the input data, the updates become more refined and specific. The learning rate, which determines the degree of change in the weights during updates, also decreases over time. This gradual decrease allows the algorithm to make large changes in the beginning when it knows little about the data, and smaller, more precise adjustments as it learns more. This process repeats for a set number of iterations, or until the changes in the map are negligible. To sum it all up, the KSOFM algorithm starts with random weights, selects an input at random, and identifies the most similar weight, the BMU. It then updates the BMU and its neighbors, with the radius of the neighborhood and the learning rate decreasing over time. The beauty of the KSOFM lies in its simplicity and effectiveness. It's a robust method for visualizing and understanding complex, high-dimensional data. It's a tool that allows us to see patterns and correlations that we might otherwise miss. So in the world of data science, the importance of KSOFM cannot be overstated. Whether you're a seasoned data scientist or just a curious mind, understanding the workings of the KSOFM algorithm can open up a whole new world of possibilities for data analysis and pattern recognition. And remember, in the realm of data, knowledge truly is power.